Hello students, in this lecture we are going to start with the chapter Electrostatic Potential and Capacitance. In this lecture we are going to study what electrostatic potential is and what was the need of studying electrostatic potential. Then we will study the electrostatic potential due to a point charge. Now let's start. The fundamental goal of studying physics is, in physics, we studies about various forces which govern the laws of nature. As we know that forces are divided into two categories, conservative force and non-conservative force. Regarding conservative force, you must have learned in class 11 what basically is conservative force. If a force is conservative, we know that some kind of potential energy is associated with the conservative force. Now, what is the motive of associating potential energy with the conservative force? The motive is, if an object has some kind of potential energy, then we can discuss other properties of the body by applying the law of conservation of energy. If a body possesses some potential energy, it can be converted into other forms of energy as well. So in this case we can apply the principle of conservation of energy. Now experiments showed that the electric force was conservative in nature. If the electric force was conservative of nature, it means some kind of potential energy was associated with the electric force. And if some kind of electrostatic potential energy is associated with the force, we required a certain quantity to understand this clearly. Now, as the potential energy is a scalar quantity, we required a quantity which must be scalar and which would be helpful in understanding the potential energy. So, a new quantity was devised which is known as electric potential, or you can say electrostatic potential. So basically electrostatic potential was devised or was introduced to study electric potential energy which was associated with the electric force, as experiment showed that electric force is conservative in nature. So first we are going to learn or understand what electrostatic potential energy is and how to find out that. Then we'll move to electric potential. Now let us study what electrostatic potential energy is. As you can see in the diagram, there is a plus Q charge kept at point O, or the origin. There is a small plus Q charge which is known as test charge, which is kept at point A and which is at a distance of r from point O. Since plus capital Q is a positive charge, the direction of electric field will be radially outward, and a force Fe will be acting on this plus Q charge in the direction shown in the diagram. Now we have considered a plus Q charge kept at origin. A test charge is kept at point A, which is small plus Q, at a distance of r from plus Q. Now let's say Fe is an electric force acting on small plus Q due to capital plus Q. Now we apply an external force on this small charge plus Q, which is sufficient enough to counter this Fe. It means we are applying a force F external in this direction. This force must have such a value that it counters Fe. It means the net force acting on plus Q charge becomes 0 and the plus Q charge starts slowly moving towards B with a uniform velocity. You must note that there should be no net acceleration. The plus Q charge must move slowly, uniformly towards B, which is at a distance of dr from point A. Now what will happen after the body comes to point B. It means plus Q charge moves from A to B and we remove this external force. As we know, then due to this Fe, the charge plus Q will start moving away from B and it will acquire a velocity. If it acquires a velocity, it means it will have some kinetic energy. Now, how the body got kinetic energy? As we know, by principle of conservation of energy, one of the energy is converted into other. So, we can say that when the body was moved from A to B, it gained some potential energy, which was then converted into the kinetic energy. So, how the body gained this potential energy? It gained the potential energy due to the work done against this Fe in moving through a small distance dr. This work done was stored in the body in the form of electrostatic potential energy, which was then converted into kinetic energy when F external was removed and the body moved from B to A, acquiring some velocity. So now, as we have discussed, external force and the electric force are equal and opposite. So the work done by external force will be equal to negative of work done by electric force. So we can find out electric work done by electric force as minus integration of F external dot dr. Dr is the distance covered. The limit will be from A to B. Since this work is done is negative, so it will be fully stored in plus Q charge in the form of potential energy. Since we are talking about the potential energy in electric field, this will be known as electrostatic potential energy. As we know, the work done is equal to change in potential energy, so it will be written as UB minus UA. As we know that the electric force is a conservative force, so it doesn't depend upon the path followed. In any form, in any path, if we bring the charge from A to B, the work done will be same. For simplification purpose, let us assume that point A is at infinity. So the work done will become UB minus U infinity, and at infinity the potential energy is assumed to be 0. So work done will be equal to UB. Now coming to the definition of the electrostatic potential energy, then it is equal to the work done by the external force, which is equal and opposite to electric force, in bringing the charge plus Q from infinity to at any point in the electric field without acceleration. Without acceleration means the net external electric force or the net external force applied on the plus Q charge must be equal to the electric force. Now moving on, we'll study what electrostatic potential is. As we have studied that in electrostatic potential energy, it is dependent upon Q. In the formula, we found out that it is dependent upon Q as the force, or you can say electric force, is equal to QE. So it will be dependent upon Q. In order to make it convenient, it is better to make it independent of Q. Now how to do this? If we divide the work done by Q, the solution will be independent of Q. Now this work done upon charge transferred is known as electrostatic potential. So electrostatic potential is defined as the minimum amount of work done in carrying a unit positive charge without acceleration from infinity to a point in the region of electrostatic field. This helps us in understanding the electrostatic potential energy and the work done better, as according to this formula, electrostatic potential is independent of the charge which is transferred. It will depend upon the charge which is creating the electric field, but it will be independent of the charge transferred. Next, we are going to study electric potential due to point charge. Consider a point charge. At this point, it is positively charged. These are the direction of electric field line. I need to find out electrostatic or electric potential at point P. Now, let us assume that there is a point charge, a unit charge, which is kept at point B, and we need to bring it from A to B. The distance between A to B is dx. and the distance of point P at which we have to find out the electric potential is R. The distance of point A from the charge plus Q is considered to be X. So we need to calculate electric potential at point P, which is at a distance of R from plus Q. This is a plus Q. We need to find out electric potential due to this charge. So as we know, at any point A, electric field intensity due to plus Q charge at any point A will be given by 1 by 4 pi epsilon naught, or Q upon 4 pi epsilon naught R square, and the R here is X. R is basically the distance of the point from the charge, and here it is X. So the electric field will become, or intensity of electric field will become, Q upon 4 pi epsilon naught X square along BA. Since it is a positive charge, the direction will be along BA. Now as we have discussed, electric potential is the work done in moving a unit positive charge from one point to another. So the work done in moving plus 1 coulomb of charge from A to B will be dW is equal to F dot dx, where dx is the distance between AB. As we know, F is equal to QE. Here Q is the charge which is being transferred, and as we have discussed, or as we have assumed that it is plus 1, so F will be equal to E. Therefore dW will be equal to E dot dx. As we have discussed in the diagram, E is in outward direction, whereas body is moving in this direction. So the angle between them is 180 degree. So I have written E dot dx is equal to E dx cos theta, and cos theta is equal to -1 as theta is equal to 180 degree. So dW will be equal to minus E dot dx. We have already found the value of E, which is Q upon 4 pi epsilon naught X square. So I have put this over here. On this will be the work done in moving from A to B. Now according to definition of electric potential, the work done is in moving the charge from infinity to a point. So we will integrate this from infinity to the point P, which is at a distance of R from the charge. So we'll get W is equal to minus Q 4 pi epsilon naught X square dot dx, integration of it. On solving, I get W is equal to Q upon 4 pi epsilon naught into R. This is the amount of work done. As you know, electric potential is work done upon charge transferred. A charge transferred is 1 coulomb. The Q dash will be equal to 1. So finally get V is equal to 4 Q upon 4 pi epsilon naught into R. This is the formula for finding out electrostatic or electric potential at any point due to a point charge. Now if we compare electrostatic potential and electric field and draw a diagram with respect to distance, we'll get this graph. As you can see, E is inversely proportional to R square. So it is more of a steep graph. This is E, this is more of a steep graph. And V is inversely proportional to I. So it is a graph of this shape. So this is the way we can compare electric field intensity and electrostatic potential. Thank you students for listening patiently. In the next class, we'll study electrostatic potential due to dipole and due to continuous charge distribution. Thank you.